So in this video we are going to see what is mutual induction. We saw self induction in the last video. Okay, this is the second type of induction, which is mutual induction. Okay, now mutual induction is very similar to self induction, just that here a secondary coil is present. Okay, so simply if we make a figure of mutual induction, it will be somehow like this: a rheostat, okay, a coil, and then a key will be there, and a battery will be there, which will be the source of the current. Okay, this will be the figure for a self induction. The difference in mutual induction is that there will be another coil here as well, okay, in which a galvanometer G is connected just to measure the current. Okay, so it is just that this is primary coil and this is our secondary coil. So this is just a difference, rest all the things are same, just a secondary coil is added. Now if we see the description, it will be similar. When K key is closed, then the current begins to flow through it. Okay, the current begins to flow through as the current is changed with the help of rheostat. It is increased with the help of rheostat. The current here increases, so the magnetic flux here also increases, and due to this, when the magnetic flux here increases in the primary coil, the magnetic flux linked with the secondary coil also increases. Okay, so when this increases, EMF is induced in secondary coil. Similarly, when current is decreased with the help of rheostat, then the magnetic flux linked here decreases. Then the secondary coil, the magnetic flux linked with the secondary coil also decreases. In this way, we can say the phenomenon in which the opposing EMF is induced in the secondary coil when current in the primary coil changes, it is called mutual induction. When we see self induction, it was just like the EMF here is induced because when the current is increased, magnetic flux is increased. When the current is decreased, magnetic flux is decreased, so EMF is produced. Okay, in self induction it was just this much, but in mutual induction it is that when the flux associated with this increases, then the flux associated with secondary coil also increases and EMF is induced in secondary coil. So this is the process in which the opposing EMF is induced in the secondary coil when current changes in the primary coil. Now as per we did in self induction, the coefficient of self induction was calculated. Here we will calculate the coefficient of mutual induction. Okay, so in self induction we saw that I is directly proportional to phi, or we can write phi is directly proportional to I. It means that the magnetic flux will change with the rate of change of current. It means that if the current is more, the magnetic flux will change more. Similarly here, see, if the current is more in primary coil, if the current is more in primary coil, then the magnetic flux linked with the secondary coil will change more. Okay, it means that the change of the current in the primary coil, it is directly proportional to change of the flux in secondary coil. Obviously, when the current here will be increased, the magnetic flux linked with it increases. Similarly, the magnetic flux linked with it will also increase. So phi s is directly proportional to IP, secondary coil, primary coil. Now constant will come. Okay, that constant is M, and now M is known as the mutual induction. Okay, or coefficient of mutual induction. It is called mutual inductance. When IP equal to 1 ampere, phi s will be equal to M, or M will be equal to phi s. So first definition came. Okay, the first definition is that the coefficient of mutual induction or mutual inductance, it is defined as the flux associated with the secondary coil when unit rate of current flows in the primary coil. So it was very simple. As in secondary coil we did, it is very similar to in, it means we did in self induction, it is very similar to this mutual induction. Just current is 1 ampere, then phi s will be equal to M, so M is equal to phi s. So first definition came, mutual induction is defined as the flux associated with the secondary coil when unit current flows through the primary coil. Now for second definition, what we did in self induction, E equal to minus d phi s by dt, isn't it? Lenz's law. Okay, so here also we'll use Lenz's law. So E equal to minus d phi s, we are using S of secondary coil. So we know phi s equal to MIP, so E equal to minus d MIP by dt. M will come outside. Okay, E equal to minus M dIP by dt. Okay, when dIP by dt, it means dIP by dt is 1 ampere per second, then E will be equal to minus M, so M will be equal to minus E. It means that second definition came, that mutual induction or coefficient of mutual induction, it is the opposing EMF minus sign opposing, E means EMF. Opposing EMF induced in the secondary coil when there occurs unit rate of change of current in the primary coil. IP by IT means rate of change of current, isn't it? So when there occurs unit rate of change of current in the primary coil, in this way the coefficient of mutual induction or mutual inductance completes. Okay, now as we did in self induction in solenoid and in plain circular coil carrying current, we will similarly do here in solenoid and plain circular coil. But see, this mutual induction is about two coils, isn't it? So in solenoid also we'll have two coils. So we are calculating the mutual induction of two coaxially placed solenoids carrying current. So see, simple figure, one solenoid. Okay, this is a solenoid. Okay, now two solenoids should be there, so combine one more solenoid here. Okay, let its length be L, and current I1 is flowing from this first solenoid and current I2 is flowing through second solenoid. So now let us consider that there are two solenoids having n1 number of turns in first solenoid per unit length, n1 number of turns per unit length in first solenoid, and n2 number of turns in second solenoid. Let L be the length of both solenoids. Okay, then we have the value of magnetic flux, the value of magnetic field. Okay, so as we did in self induction, first we'll calculate magnetic field and then we'll just put it in the law. We know phi will be equal to NBA. Okay, this is, I am talking this about self induction. We'll calculate B, then phi will be NBA, put the value of B here, and then we know that phi equal to Li. This is all about self induction. We calculated I. Okay, but similarly here in mutual induction, no difference at all. Just calculate the B first, but here we have to calculate for both solenoids. Okay, so B1 will be equal to, we have the formula, B1 is equal to mu naught N1 I1. Okay, I1 and I1 we are taking off U. Okay, so as I said पहले भी ये बात बता चुके, n equal to n by n, and I showed how n equal to n by l. You can see my previous video if you forgot. Okay, so B1 will be equal to mu naught N1 I1 by L. This is our first equation, but we also know that phi equal to NBA. Okay, we are calculating the flux associated with the secondary coil now. Now see, here comes the confusion. B1 यहाँ पे होगा, पर we are calculating flux in secondary coil. Why? Because see, the flux will change in secondary coil, isn't it? जब current first coil से pass होता है तो secondary coil में change होगा ना. If you see this figure, when the current flows through primary coil, flux is changed here, then flux is changed here, and EMF is induced. So we are basically talking about secondary coil when we are talking about flux. Okay, so we'll just calculate phi 2 equal to n B1A. Okay, B1A, we'll use B1 of this and phi 2 क्योंकि flux तो इसका बात कर रहे हैं. So basically the flux associated with the secondary coil when the current flows through the first solenoid. When the current flows through the first solenoid, so we are using B of first solenoid. Okay, so it will be mu naught N1, and ये N तो इसका यूज करेंगे. I'm gonna clear this again. See, B1 equal to mu naught N1 I1 by L. You understood this? Okay, now we are going for phi. When we are talking about phi, we are talking about the secondary coil. Now it is the flux associated with the second solenoid when the current flows through the first solenoid. So when it flows through the first, we are calculating flux of second solenoid. So number of coils will calculate of second solenoid, but current flows through the first solenoid, so we'll use B of first solenoid. Okay, so mu N1 N2 I1 by L A. This will be our equation. Okay, after calculating, but we know phi equal to Mi, and if we write in this symbolic notation, phi 2 equal to Mi1, phi 2. Okay, because secondary coil and when current flows through primary coil, so phi 2 equal to Mi1. So just equate these both. Okay, when we equate these both, we'll get M2 I1 will be equal to M2 तो इसको we are calculating mutual induction of secondary coil first. M2 I1 will be equal to mu naught N1 N2 I1 A by L, isn't it? Now then just calculation left, M2 will be equal to I1 and I1 cancel, so mu naught N1 N2 A by L. Okay, similarly if we calculate the mutual induction of first solenoid, it will be M1 mu naught N1 N2 A by L. No difference, because see, current का तो कहीं पे बात ही नहीं है, I1 I2 का बात ही नहीं है कहीं पे. So basically the mutual induction is mu naught N1 N2 by N1 into A by L. This is the expression for mutual induction. And if you compare with self induction it was mu naught n square A by L. Okay, here mu naught A by L, everything is same, just यहाँ पे n square, because we are only using one n here, तो n1 n2, so उतना ही difference है बस. Okay, so when you do the derivation, it is very simple. You can have a look at your notebook, it's very simple. And again, as we did for plane circular coil, we'll do for plane circular coil here. Here we'll make two coils because we need one primary coil and secondary coil, so two coils. Okay, concentric we'll make it. Suppose this smaller one is first coil, so I1 current is flowing, bigger one is second coil, I2 current is flowing, let its radius be R1, let its radius be R2. So simple. Let us consider two plane circular coils having N1 and N2 number of circular coils of radius R1 and R2 respectively. So the flux associated, okay, first किसका calculate करना, you can decide yourself. So let's calculate the flux of secondary coil first. Okay, so for secondary coil flux we will calculate the B of first coil, जैसे solenoid में के वैसे. So B1 we know for a plane circular coil, center of plane circular coil, it is mu1 n1 I1 by 2 R1. This is the formula. Okay, है ना. Now phi 2 will be equal to, again I showed you how it became phi 2 equal to n2 B1 A. Okay, so just put the value of B1 here, we'll get mu naught n1 n2 A I1 by 2 R1. Okay, but we also know phi equal to mi, so in symbolic notation phi 2 equal to mi1. Okay, flux linked with secondary coil when the current flows through the primary coil. So just equate these two and you will get this value. Okay, for if you want to calculate the mutual inductance of the first plane coil, then just no difference, I का तो बात ही नहीं है, so see, no difference. So basically the formula is same. Okay, just एक difference है, R1 and R2 का difference है, nothing else. So this is all about mutual induction. It's basically similar to self induction. If you didn't understand the video, you can rewind it, and you can mention your queries in the comment section, and please do not forget to subscribe.